Good morning, everyone. Today is March 24th. It is 9:30 about. Today what I'm going to do is I'm going to go through the Topic 7 test study guide. Now, I'm going to be going through a few of the beginning questions that we went through. Um, and I'm going to go all the way. I'm going to try to go to number 10 today. All right. So, strap in. This is probably going to be a longer video. Um, but this is one of the chapters that we kind of struggled on a bit more. So we're going to be working on this one. And the very first thing before we even start is it says the formula for area of a rectangle is, well, we know the area equation is length times width. All right. I actually want to add another equation right here. This is the perimeter equation, P. This is 2 times your length plus 2 times the width. All right. And the reason I'm adding these, or this one, is simply because it comes up in number 1 right here. All right. So we're going to go ahead and we're going to go through all of these questions, 1 through 10. And if you have any questions, please, again, remember my email is open. I will write down my email at the end of the video so you guys can um, send any questions my way. So, number 1 says, look at the diagram on the right, which is this little square right here. All right. I'm sorry, rectangle. Write polynomials that represent the perimeter and area of the rectangle. So if you guys don't remember what a polynomial is, I'll give you an example. It was really x to the 5th plus b x to the 4th plus c x to the 3rd, and so on. All right. So if you don't remember this, this is just kind of to clarify some questions for you. All right, because I know that some of these questions would be coming up later. All right. So it says that represent the perimeter and area of the rectangle. Well, I'm going to do perimeter first. Um, and I have already identified that my perimeter equation is 2 times the length plus 2 times the width. So I need to identify what the length and the width are. What I'm going to do is I'm going to notice that I have two sides that have been labeled. That side right there and this side right here. Well, I know that length is really what we mean from top to bottom, so I'm going to say that x is our length and x plus 2 is the width. So I'm actually going to plug the length and the width into my perimeter equation above. So I'm going to rewrite it. P equals 2 times the length plus 2 times the width. Well, we know that the length is x, so we're going to say 2 times x. All right, plus, and then 2 times the width, and we know the width is x plus 2. So we're going to say 2 times x plus 2. Well, this probably looks pretty familiar. If anybody knows the distribution rule, we have to distribute these 2's into the appropriate parenthesis. So we're going to go ahead and do that now. 2 times x is simply 2x. 2 times x is simply 2x, but then we have to do 2 times 2, which is also 4. So once we have this, we're pretty much guaranteed to have this correctly done. The last thing that we're going to do is combine like terms. Now, these parentheses right here can actually go away. So we can rewrite it as simply 2x plus 2x plus 4. And a lot of you are already realizing that the two x's can be combined. All right, so 2x plus 2x is simply 4x. The 4 gets carried down, and our perimeter is now 4x plus 4. So we can go ahead and just say 4x plus 4. Awesome. Now we're halfway done with this problem, but the next portion gets a little bit easier. The next portion says we need to find the area of the rectangle. Well, The area of the rectangle is simply the length times the width. We already know the length, which is x. We already know the width, which is x plus 2. All I have to do is say length times width. So I'm going to go ahead and erase some of my work for perimeter. If you need it, I would suggest pausing now. Okay. So, just going to erase that. Now we're going to do area. I'll do this in a separate color. I'll do this in red so you can, let's change it to dark blue. So, we're going to go ahead and do area. And we know area is length times width. Well, when I do area, when I do multiplying polynomials, I like to use our box method. So, notice right now, all I did was I said, well, it's length times width, so length is x times x plus 2. Now, we talked about this a while ago, but for those of you who are struggling to remember, and that's okay, all of us forget things time to time, we are going to do the box method, all right? And the reason we do the box method is because I find it to be the simplest version to take care of multiplying polynomials. So, uh, the box method, for those of you who may be forgetting what it is, we draw a box with the dimensions of terms in our multiplying. So if we look right here, there is one term. So the box is going to be 1 long, and there are 2 terms here, so it's going to be 2 wide. What I'm going to do is I'm going to put the first term right here. I'm going to put it on the left, and then my second term, x plus 2, I'm actually going to put on the top, x plus 2. And from here, I'm actually just going to multiply them out. So, x times x is x squared. X times 2 is actually 2x. And we're going to rewrite this outside. X squared and 2x really means x squared plus 2x. And here we have it. This is actually our polynomial for the area. Again, I know that's a bit wild for some of us. Maybe we forgot it. So please, again, message me if you have any problems or are just a bit lost. But that's number 1. So we're going to move on to number 2. Number 2 says, look at the diagram on the right. Write a polynomial that represents the area of the shaded region. Now, shaded region is very important. If we notice, the shaded region is everything outside, all right? What we're going to do is we're actually going to go ahead and find the area of the large rectangle. If I can choose this red. We're going to find the area of the large rectangle. And then we're going to take away the area of the small rectangle. And for those of you who are wondering what I mean by take away, I mean subtract. So what we're going to do, and I'll write it out for this, area of shaded region equals area of large rectangle minus area of small rectangle. All right, so now that I've written it out, I really know what I'm going to do. So first things first, I need to find area of the large rectangle. So again, if we look up here, area is length times width. So the length of this large rectangle is 2x. So I'm going to go ahead and say length. The width happens to be x plus 5. So I'm going to go ahead and start, and I'm going to say, well, the first thing I need to do is find the area of the large. So I'm going to say area of large. All right. So we know that it's length times width. All right. The length happens to be 2x. The width happens to be x plus 5. So we're going to say length is 2x. The width is x plus 5. Okay, so again, I'm going to do my box method, all right? I know that this length, 2x, is only one term, so it's going to be a 1 by, and then x plus 5 has two terms, the x and the 5. So I'm going to go ahead and do a 1 by 2 box method. I'm going to say 2x on the left, x plus 5 on the top. Now, 2x times x is 2x squared. 2x times 5 is simply 10x. So I know the area of the large rectangle is 2x squared plus 10x. So that's the area of my large rectangle. Now the area of the small rectangle I need to find as well. So we're going to do length times width. Again, it's a rectangle, length times width. The length of my small rectangle is 3. So I'll just put a L there. The width is 4. Oops. Why am I not just erasing? Yeah, it's 4, so let's go ahead and put width. So the area of small rectangles, length times width. Well, the length is 3, the width is 4. 3 times 4 is 12. All right, here's my last thing. I know I need to find the area of the shaded region, which means I want to take the area of the large rectangle and subtract or minus the area of the small rectangle. So I'm going to say, let's put this in a new color. I'll put it in brown. Hopefully that comes out. The area of the shaded, so area of shaded is the area of the large rectangle. Well, that is 2x squared plus 10x minus the area of the small rectangle. The area of the small rectangle is 12. Well, okay. There's not much I can do here in terms of combining like terms or anything like that. So I can actually ignore the rectangles, and I can say the area of the shaded region is simply 2, oops, pressed a button on my pen here, 2x squared plus 10x minus 12. Again, I cannot combine any like terms, so this is legitimately my polynomial that represents the area of the shaded region. All right, so that's all I need to write for number 2. Let's go ahead and look below. So number 3 is very similar to number 1 above. It says, write polynomials that represent the perimeter and area. I'm going to do this one a bit faster because we've already done something like this. The first thing I want to do is remind myself of the equations. So looking back, area is length times width, perimeter 2 times the length plus 2 times the width. I'm going to start with perimeter. First things first, we need to identify the length. I'm going to say the length is 2x. I'm sorry that keeps happening. 2x minus 1. So that is the length. The width is x plus 3. So let's go ahead and say the perimeter is going to be 2 times the length plus 2 times the width. Well, our length is 2x minus 1. Our width is x plus 3. And here comes the distribution step. So we're going to go ahead and distribute this 2 in front and this 2 in the second one. So 2 times 2x is simply 4x. 2 times a minus 1 is going to be a minus 2. Plus 2 times x is 2x. 2 times 3 is 6. All right, the last thing I have to do is combine any like terms. What I'm going to do with that then is rearrange all of these terms so that similar like terms are next to each other. So 4x is similar to 2x, and the minus 2 and the plus 6 are similar. So I now know all I have to do is combine these terms, and I have my perimeter. 4x plus 2x is 6x. Negative 2 plus 6 is plus 4. So my answer for the perimeter is simply 6x plus 4. That's pretty nice and easy. Area is going to be very quick. We know the area is going to be length times width. The length we've already discussed as 2x minus 1. The width, x plus 3. Now, again, I'm going to use our box method. So, I'm going to count how many terms each one of these has. So, the first term, 2x minus 1, well, that's actually 2 terms. And then x plus 3 has 2 terms as well. All right, so I need to make a box that is 2 by 2. All right, and I'm going to put my first polynomial on the left side, so 2x minus 1, and the second polynomial, x plus 3, on the top. And what I'm going to do right now, I'm going to go ahead and multiply these. So 2x times x is 2x squared. 2x times 3 is 6x. Negative 1 times x is negative x. And negative 1 times 3 is negative 3. Now what I need to do after I do that is simply write them out. So I'm going to do this like I'm reading a book, left to right, top to bottom. So 2x squared plus 6x minus x minus 3. My last step for the area is actually just to make sure I combine any like terms. And we can notice that 6x minus x can be simplified. So we're going to go ahead and say this equals 2x squared. 6x minus 1x is simply 5x. And we have minus 3. So our answer for this one, for the area, is 2x squared plus 5x minus 3. And we are actually finished. So that is number 3. Again, I would suggest if you were confused about that, please just go back, rewatch that question, and post your comments or questions. Number 4 is find the product of a monomial and a polynomial. Really what this is asking us to do when we're finding the product, it really means do the box method. You can also feel free to just distribute the x. That is a little bit harder. I'm going to do the box method simply because that's what I've been doing this entire video. So the first thing I'm going to do is identify how many terms are in each polynomial. So x literally has one term. 3x squared plus 5x is 2 terms, the 3x squared and the 5x. So I'm going to make a 1 by 2 box. I'm going to put x on the left, 3x squared plus 5x on the top, and I'm just going to multiply these ones out. 3x squared times x is 3x to the third. 5x times x is 5x squared. So my answer is 3x to the third plus 5x squared. That's it. That's all you have to do. I'm going to do the same thing with b here. I'm going to do it a little bit faster. Here we go. All right. Negative 5k squared is one term. K to the fourth minus 3k cubed is 2 terms. I'm going to go ahead and do my box method. A 1 by 2 box. Negative 5k squared. K to the fourth times, and negative 3k to the third. All right. So this one is going to be a bit messy. Let's make sure we do it correctly. All right. negative 5k to the second times k to the fourth is simply, and let me change pens so we can see it, negative 5k to the sixth. Remember, when we multiply variables with the same base, so k and k, we add their exponents right here, so 4 and 2. All right, now we're going to go ahead and do negative 3 k to the third. So negative 5 times negative 3 is positive 15. K to the second times k to the third is k to the fifth. So what we're going to do now is, we've gotten all that written out, we're going to say negative 5k to the sixth plus 15k to the fifth. All right, B is pretty much done. So we're going to scroll down to the next page. Go ahead and flip that page for some of you. It says for questions 5 and 6, write the polynomial. Okay, so what we've been doing up here, write the polynomial so that the exponents decrease from left to right. So basically we want greatest to least. All right. Then identify the degree and leading coefficient. All right, so let's go ahead and do number 5 first. What we want to do is we want to identify the term with the biggest exponent. So we're going to go through, and I'm going to be writing in exponents in red. So negative 6x plus 2 plus x squared minus 3x to the third. So negative 6x is really negative 6x to the first. And the reason we know this is because when exponents have a value of 1, they actually do not have to be typed down. All right, plus 2. Well, this actually means that the variable x has an exponent 0, which means that this one is going to go to the dead last. All right, so we're just going to throw that over. X squared, well, that exponent is simply 2. Negative x to the third is 3. So what we're going to do now is we're going to rearrange these, all right? We can actually tell which ones have the largest exponent. So we saw an exponent of 3. So this term right here, negative x to the third, is going to go first. So negative x to the third. It has the largest exponent, which is 3, so it gets put in front. We then look for the next largest exponent, which is 2. So we're going to take positive x squared, so plus x squared, and put it in front. Now, we keep checking. We know that negative 6x to the 1 has the next largest exponent with a value of 1. So we're going to say negative 6x to the 1. And we knew that our plus 2 went to the end, so we throw it at the very end. This is now standard form. If you notice, our exponents decrease and they go from greatest to least. So our exponent goes 3, 2, 1, 0. All right. I should actually write x to the 0. So I'll write that in red so you guys know what that actually means. It means x to the 0, and that effectively goes away. All right, so we're going to go ahead and then find the degree and the leading coefficient. Now, the degree and the leading coefficient are all in front here. They are all wrapped up in here. The degree is the highest exponent, and we know that the highest exponent happens to be 3 right here. So we're just going to say the degree is 3. The leading coefficient is the number in front of our leading term. So our leading term is negative 3x to the third. The number in front of it happens to be negative 3, so we're going to go ahead and just write negative 3. That is all degree and leading coefficient are. There's no tricks. There is no gotcha moments. It is literally just that. All right, let's try number 6 now. 6 should be faster now that we have all of our ideas out of the way. So let's go ahead and identify the values of the exponent. Okay, so number 6, 15 plus 26y plus 8y squared. Well, this really means, okay, 15, again, we've talked about how it doesn't have an exponent, so it goes to the back. Great, it's going to be dead last. 26y is actually 26y to the first, and 8y squared has an exponent of 2. So again, let's talk about which one has the greatest exponent. There are three exponents. X to the 0, which is on the 15. That's already at the back. I'm sorry, y to the 0, sorry. We can tell that the term with the largest exponent is actually 8y squared, which is right here. And then the next largest term would be 26y to the first. So we're going to say 26y. And the last term we told ourselves we would throw it to the back is simply 15. So now all I have to do is identify my degree and leading coefficient. Again, all of that can be found in the first term. Our degree is the largest exponent, which is 2. Our leading coefficient is the number in front of our first term, which is 8. All right, so we are very close to being done. We are 4 questions away. All right. Number 9 and 10 you could actually do ahead of me. They are literally just box methods. All right. Number 7 and 8, I bet most of you can do, but let's assume that we kind of forgot what to do. Number 7 says find the sum. Really, what sum means is add them up. Find the answer of addition. Find the sum of the following polynomials. So what this means is combine like terms. All right. So we're going to go ahead and when we're doing addition of polynomials and only addition of polynomials, we can actually ignore the parentheses. So what I'm going to do is I'm going to rewrite this entire problem, 7a. I'm just going to rewrite it without parentheses. So our problem says 3x squared plus 4x plus 14 plus negative 4x squared plus 21. I'm going to go ahead and get rid of these parentheses. First thing I'm going to do, 3x squared plus 4x plus 14. I would say plus negative 4x squared. I'm really just going to say minus 4x squared plus 21. All right, now that I've done that, I'm going to go ahead and rearrange terms so that they're next to their like term. What this means is a like term has to have two things to combine. It has to have the same variable, and it has to have the same exponent. So I'm going to go ahead and put these next to each other. We've done a bit of combining like terms earlier, but I think it's important to always stipulate what like terms need. So we're going to go ahead and look for things with the same variable and same exponent. I noticed that 3x squared has a like term, so I'll put 3x squared first. 3x squared and negative 4x squared have the same variable and same exponent. So I'm actually just going to go ahead and cross those out right now. I'm going to then go ahead to move to my next term, 4x. So I'll say plus 4x. 4x does not have a like term. So we'll just kind of write that there. And then the last one is going to be plus 14 plus 21. And notice these ones are like terms because they don't have a variable and they don't have exponents. So that actually means that they are like as well. And from here, we're just going to actually do some of our addition. So 3x squared minus 4x squared. Well, 3 minus 4 is negative 1. So we're going to have negative 1x squared. You could also just write negative x squared. All right. 4x cannot be combined with anything, so it'll just be plus 4x. And 14 plus 21 is simply 35. So our answer, the sum is negative x squared plus 4x plus 35. That's it. Let's try B now. So 7B, I'll change my pen color to dark blue. And all I'm going to do is I'm going to rearrange my variables. I know that I can, rearrange my terms. I know that I can ignore my parentheses. So what I'm going to do is I'm going to go ahead and skip that step right now. I'm just going to go straight into getting my like terms next to each other. And I'm going to start with the largest exponent terms. So I noticed that negative 5d to the third and 8d to the third have the largest exponent. So I'm going to write negative 5d to the third plus 8d to the third. I'm going to move on to my next largest exponent, which happens just to be plus 2d squared. My next largest exponent would be plus 3d plus 6d. And that's 6d, not the number 60. And then the last term I actually have is just a minus 1. Yeah, that goes to the end. All right, so last thing I need to do is just combine like terms. Negative 5d cubed plus 8d cubed is simply 3d cubed. Nothing can be combined with 2d squared, so it's simply going to stay 2d squared. 3d plus 6d is 9d. And the minus 1 is just sitting at the end. So you'll notice that once you feel a bit more confident with how you're working, it only takes about 2 steps. All right, so we're going to move to number 8, and then 9 and 10 will be a walk in the park for us. All right, so we're going to find the difference of polynomials. If you don't know what difference means, it means subtraction. All right, so subtraction. There's one extra step on this from number 7 doing the sums. Difference is very similar to sums. The only difference is that you're going to go ahead and distribute this negative sign right here. So what we're going to do is we're going to distribute the negative sign into every single part of the term after it. So the first term stays the same. It's simply going to be 4a to the third minus 2a plus 1. Now, the next one, when you distribute this negative, it becomes a plus sign. But every sign in this second polynomial is going to change. So a cubed is now going to turn to a negative a cubed. A negative times a negative is actually positive, so it'll be a positive 2a. And then this positive 3 is going to turn into a negative 3. All right, now if you notice, after I've distributed the negative, this looks like a sum. This looks like number 7. So I'm going to ignore the parentheses, and I'm going to rewrite it so that like terms are next to each other. So I'm going to go ahead and find my terms with the highest exponent. So that would be 4a to the third, and then the negative a to the third. And then I have minus 2a right here, plus 2a right here, and finally a plus 1 and a minus 3. All right, with that, I just need to combine like terms. So 4a to the third minus 1a to the third. Remember, if it doesn't have a number, it's actually a 1 right here. So 4 minus 1 is simply, 3a to the third. Negative 2a plus 2a actually cancels out. So I don't actually have to write anything for that. I could write 0a, but 0 times anything is just 0. We don't have to write plus or minus 0. So these cancel out. The last thing I have to do is plus 1 minus 3. Well, 1 minus 3 is a negative 2, so it's going to be a minus 2. That's all difference is. Now I'm going to go ahead and I'm going to repeat the process for 8b right here. So again, the first thing I'm going to do is distribute that negative in the center. So this minus right here is going to be distributed to the polynomial after it. So the first polynomial, 2y squared minus 4y plus 1, that one stays the same, literally does not change. The minus sign will then turn to a plus, and everything in the second polynomial, its sign will change. So negative times a negative is a positive, so this negative y squared becomes positive y squared. Negative 3y becomes positive 3y, and plus 2 becomes minus 2. All right, we're going to work these to put them next to their like terms. So we're going to look for the terms with the highest exponent, which is 2y squared and y squared. So 2y squared plus y squared. Then the next two largest terms with their exponent, minus 4y plus 3y. And lastly, plus 1 minus 2. All right, 2y squared plus y squared is 3y squared. Minus 4, or I'm sorry, negative 4y plus 3y is negative 1y, or simply negative y. And 1 minus 2 is minus 1. All right, or a negative 1. So that is number 8. So we have covered a lot today. We're not done, though. We have 2 more problems, and they are product, and product means box method. All right. Box method, easy enough. We're going to find how big my box should be, and then we're going to go ahead and just multiply them out. So 9a is the product of a monomial and a polynomial. So if you notice, the monomial only has one term with x. The polynomial is 3x squared plus 5x plus 2. So this has 1, 2, 3 terms. So 1 by 3. So I'm going to make my box 1 by 3 here. And again, your box doesn't have to be super nice. Mine are always kind of weird. We're going to put the first polynomial on the side and the second polynomial on the top. All right, and I'm going to go ahead and multiply these. 3x squared times x is just simply 3x to the third. 5x times x is 5x squared. 2 times x is 2x. And we want to write them as an equation, so we're going to say 3x to the third plus 5x squared plus 2x. None of these can be combined because though they have the same variable, they do not have the same exponent. All right. So with that, we're going to go ahead and that is actually 9a. So we're just going to do 9b very quickly. We're going to notice that this is, again, a monomial and a polynomial. So monomials, by definition, have one term. This polynomial has k to the 4 minus 3k to the third minus 8k. This is 3 terms, so it's going to be a 1 by 3 box again. My first monomial, negative 5k squared, goes in front, or on the left, sorry, and then my polynomial goes on top. All right, so we're going to take this one step at a time. Let me fix these lines in here because they look atrocious. A little bit better. All right, negative 5k squared times k to the 4 is negative 5k to the 6. Again, we talked about how to multiply exponents. All right, next one, negative 3k to the third times negative 5k squared. Negative 3 times negative 5 is 15. K to the third times k to the second is k to the fifth. Again, exponents add. And lastly, negative 8 times negative 5 is positive 40. K times k squared is k to the third. So I can rewrite this as negative 5 k to the sixth plus 15 k to the fifth plus 40 k to the third. All right, everyone, that is number 9. Number 10 is actually a little bit more, I'll say it's more difficult, simply because instead of a monomial times a polynomial, it is the product, so again, box method, of 2 binomials. For those of you who are like, why are we doing box method instead of FOIL? You can do FOIL. There's nothing wrong with FOIL. I personally like box method. It's really nice for visualization. So, box method. we need to find the amount of terms first. So y plus 2 times y minus 7. So that's 2 terms in the first one and 2 terms in the second. So it's going to be a straight box of 2 by 2. We're going to put the first polynomial on the left, the second polynomial on the top, and we're going to multiply these out. Y times y is y squared. Negative 7 times y is negative 7y. 2 times y is 2y. 2 times negative 7 is negative 14. I'm going to write this out just like I'm reading a book. So top to bottom, left to right. So y squared minus 7y plus 2y minus 14. The last thing I have to do is combine any like terms. There are only 2 terms that can be combined, negative 7y and 2y. So y squared stays as is. Negative 7y plus 2y is negative 5y minus 14. That's it. That is the product of these two binomials. 10b is our last problem for today, which I'm pretty sure some of you can be like, finally. All right, we're going to do the same thing. Find our dimensions of this box method. So 4r minus 9 times r plus 2. So 4r minus 9 has 2 terms. R plus 2 has 2 terms. So our box is going to be a 2 by 2. So 4r minus 9 goes on the left. R plus 2 goes on the top. And we're simply going to multiply these out. 4r times r is 4r squared. 4r times 2 is 8r.
Sorry, I didn't get that.
Sorry about that, everyone.
I didn't follow what you said. Can you phrase it another way?
Sorry, everyone. My computer, I accidentally pressed a button. All right, so let's see. Negative 9 times r is negative 9r. And lastly, negative 9 times 2 is negative 18. So we're going to go ahead, write it out like a book. Top to bottom, left to right. 4r squared plus 8r minus 9r minus 18. Again, the things that can be combined, 8r and negative 9r. We're going to go ahead and say 4r squared cannot be combined, so this one does not change at all. So we're going to say 4r squared. 8r minus 9r is negative 1r, or simply negative r, and the negative 18 just gets brought down. So this is it, 4r squared minus r minus 18. That is 1 through 10 on the Chapter 7 test study guide. Now, I know that some of you may have had some questions here. Please feel free to email me. All right. Oh, you know what? We'll do we'll do 10 C, D, E, and F tomorrow. Because I totally forgot that they were there. We'll finish the rest of this up tomorrow. I think 2 pages is pretty good for one day's work. All right. If you have any questions, email me, message me on Google Classroom. And as always, stay safe, wash your hands, get some rest. All right. That's it for us.